Hello everyone and welcome back to our videos. Today we will talk about the cooling system of engines, and we will talk about the reciprocating engine cooling system and the turbine engine cooling system. At the beginning we will take a look and we will have an introduction. Aircraft engines are designed to convert heat energy into mechanical energy. Only about 1/3 of this heat converted into useful work. The remaining 2/3 of the heat energy is wasted and must be removed from the engine to allow the engine operates at its peak efficiency. So, the primary purpose of the cooling system is to remove the unused heat produced by the combustion. Reciprocating engine. This is the first type of engine we will start to talk about its cooling system. Heat energy transformation. Not all of the heat energy that is generated from the combustion process is converting into useful work, so that approximately 30% is converted to useful work, and from 40 to 45 is expelled through the exhaust. The remaining 25 to 30% is absorbed by oil and metal mass of the engine. It is this heat that is removed by an aircraft cooling system. So our cooling system that we will talk about, it will remove from 25 to 30% from the heat, and that's our topic for today. The reverse effects of the energy of the heat energy if it is not removed. The first thing, decrease in volumetric efficiency. After that, excessive heat shortens the life of the engine parts. Reduce the ability of oil to lubricate. The method of cooling an engine: direct air cooling or liquid cooling. Almost all reciprocating engines are air-cooled engines. All air-cooled engines utilize cooling vents that are either cast or machined into the external surface of the cylinder, barrel, and heads. The cooling vents provide a very large surface area for transferring heat into the surrounding airflow. Today, aircraft engines use steel cylinder barrels that have vents machined directly onto their surface. These barrels screwed into aluminum cylinders heads with vents that are cast with head. More vent area is provided around the exhaust port because it is the hottest part of the cylinder, while the intake portion has few cooling vents because the fuel and air mixture cools this area sufficiently. This the vents of the reciprocating engine. Cooling vents around the exhaust port is more than the intake port. And we know that because the exhaust it has more heat. After we talked about the vents of the engine and its function that help for cooling the cylinder of the aircraft, and it considered to be as air cooling system. Now we will talk about the cowling. An undesired side effect of air cooling is the penalty imposed by increasing drag. The drag problem became unacceptable once aircraft airspeed over 120 miles per hour. Radial engine cowling. To reduce drag on aircraft equipped with a radial engine, the tail end ring or speed ring was developed. The tail end ring is an airfoil shape produce an aerodynamic force that smooths the airflow around the engine and improve the uniformity of air flowing around each cylinder. Tail end ring can reduce drag by as much as 11% on aircraft. After that, we have NACA cowling. In the early 1930s, an engine cowling known as NACA cowling. This streamlined cowling covers all portion of a radial engine and extends all the way back to the fuselage. All NACA cowling have an airfoil shape that actually produces thrust by converting the air into a solid jet blast as it leaves the cowling. The opposite engine cowling. Early opposite engines, the cylinders stuck out into the airstreams to receive cooling air. Since the cylinders were directly behind each other, a thin sheet metal hood had to be installed on each side of the engine to force air down between the cylinders. On modern opposite engine, the cowling surrounding and encloses the entire engine, as we see in this figure. This the two forward facing opening for the air, and this the engine cowling. With this type of cowling, cooling air enters through two forward facing opening and exits out one or more opening in the bottom rear of the cowling. The rest of cowling is sealed with rubberized stripes to prevent excessive air leakage. Because of the ram effect produced by forward motion and prop wash, cooling air enters a cowling at pressure above ambient. This produces what is known as pressure cooling. To facilitate the pressure cooling process, the outlet on most lower cowls is flared, so that when the outside air flows past the opening, an area low pressure is created and draws inlet air down through the cylinders into the lower side of the cowl where it can exist. And this the flared of the cowling.